I'm Rodney Gush. I'm the Senior Application Scientist at Moor Instruments. Moor Instruments itself was founded in 1987 by Dr. Dave Boggett here in Axminster in East Devon. About 20 of us work at Moor headquarters, researching, developing, producing, selling and servicing a range of optoelectronic devices for assessing tissue blood flow and tissue oxygenation. And these devices are used for clinical and for research applications. Our background in clinical assessment includes laser Doppler burn imagers, helping surgeons to accurately decide if skin grafting is necessary and, just as importantly, when it's not necessary. We've recently developed a laser speckle imaging system, and the system recently developed used during reconstructive surgery following mastectomy for breast cancer. This is used to help surgeons identify and avoid free flap areas with poor blood flow to reduce post-operative complications. There's an emerging technique that is slow and requires fluorescent dye injection. The challenge we faced was to extend our range of non-contact imaging devices into the world of endoscopy. The interest in endoscopy was because we knew that the indocyanine green fluorescence technique was being used, and we also knew it was being used endoscopically for gut surgery. You've always got a danger of the tissue dying, and if you can get early warning of that with post-operative monitoring and even earlier warning of the potential by seeing the blood flow during the surgery and immediately post-surgery, then you're onto a huge advantage in preserving the tissue and making a successful operation long term. Moor was collaborating on a European project headed by Colin Murdoch at the University of Dundee. We already knew Prof Faisal Khan at Dundee. Colin brought in Nick. They identified KTP as a suitable source of funding and support.
My name is Nick Stajic, or easier Nick. I work at University of Dundee School of Science and Engineering, where I teach and do research in medical devices. And KTPs are a unique opportunity for academics to embed themselves in companies and work closer on the product level. The product range that Moor Instruments has there's an established range of products for free space view onto tissue. It's part of their long-term plan to move their instruments into imaging inside human body. So Colin Murdoch is co-investigator on this project, and Colin has had a lot of experience in working with a variety of medical device and biomedical companies in general.
We had 10 applicants and we're lucky to recruit Dr. Ranjit Kumar.
He came with a strong background in optics from Indian Institute of Technology, which are one of the top universities in the world, and he's brought in expertise in fundamental optics, and he's also brought in his meticulous approach to breadboarding the design, prototyping it, and linking up and adapting to the circumstances and also the needs Moor Instrument has. The project started in March-April 2020, which was exactly the time when the pandemic hit big way. The main challenge was that KTP associate Dr. Ranjit Kumar couldn't be in Axminster from day one. So he spent the summer at a different location in London. And then within that time, after he was in Axminster, it was challenging to have full-time access because of the rules generally companies had.
Another challenge was that Ranjit, our KTP associate, got another post at a university before the end of the project. Fortunately, the others involved at Dundee were able to step in and take over and complete the task. In spite of all the practical difficulties, a successful endoscopic laser speckle blood flow imager has been produced, and it's more successful than originally envisaged.
What we have, and I think what's unique to the KTPs, we actually have a box that is not like 100% product, but looks like a good-looking prototype, which was fully assembled and built by Moor Instruments.
The red, green and blue LEDs were already being used for real-time video imaging. They're now used spectroscopically to assess changes in tissue oxygenation.
We were able to bring in a unit from University of Dundee to help us emulate the situations that are in the clinic. It has gone through some preclinical tests, and we're currently analyzing that data and preparing it for publication which will hopefully get us to the next stage to have more preclinical tests and then move on to clinical tests.
And when the publication is in progress, we'll explore the preclinical market for early commercialization of the endoscopic laser speckle technique.
Our main aim is, together with the new results we hope we can demonstrate, is to pursue new funding routes, both on a commercial side in collaboration with Moor Instruments, but also in parallel more fundamental research where Moor Instruments would of course be involved in terms of expanding overall their technology and the endoscopy side. So the whole spectrum of technologies is fast advancing. Cameras are getting smaller, electronics is getting faster, software is getting easier to use, so there's a lot of aspects we hope we can help in the future.
For Moor Instruments, yes, we recognised an opportunity and knew that we didn't have the right skill set. But I think the great advantage of a KTP associate is that they are truly focused all the time on what the final aim is.
So the application process was assisted by KTP North Scotland, and we've throughout the process discussed the relevant questions, and as a form it was far more enjoyable than your usual funding applications.
Emma and Laura at North of Scotland KTP and Andy Treen, our local KTP advisor, were enormously helpful with environment of travel funds to other areas to maintain the project pace.
And that was actually really helpful because it allowed us to evaluate more components, more devices, and build a better instrument. Flexibility with working with KTP North Scotland, that really helped. We knew in advance that if there was an issue we could ask immediately, we get an answer the same day, and we could discuss it in detail. And not every wish can be satisfied, but most of them were, and that was really helpful. I'm really keen to explore more KTP projects because it allows us to fund a company or help fund a company to engage in our courses. The closeness we can achieve with the company and hopefully contributing without some meticulous researchy aspect within the problems they need are really rewarding for us as scientists and engineers.
Knowledge Transfer Partnerships, or KTPs, are unique collaborations that drive innovation and create positive impact. Each KTP enables a forward-thinking business to partner with one of the UK's world-class knowledge bases. Together, they develop and deliver a strategic innovation project led by a talented graduate known as a KTP associate. At least 50% of eligible KTP costs are funded by Innovate UK.